Imagine stepping into a booth, you press a button, in an instant you vanish. You reappear in another booth, miles away. This is teleportation, the instantaneous transfer of matter from one point to another without crossing the physical space in between. Teleportation has captivated our imaginations for centuries. It features heavily in science fiction, literature and film. But what are the scientific realities behind this fantastical concept? Could teleportation one day become a reality rather than a fantasy? The implications of teleportation are vast. It could revolutionize transportation, communication, and even space exploration. Imagine teleporting to work, instantly sending packages across the globe or beaming humans to distant planets. However, teleportation also presents potential dangers and ethical dilemmas. We must approach this technology with caution and responsibility. The power to teleport is the power to reshape our world for better or for worse.
To understand the potential of teleportation, we must dive into the strange world of quantum mechanics. One particularly intriguing phenomenon is quantum entanglement, a bizarre connection that can exist between two particles. Imagine two particles linked in a mysterious way. No matter how far apart they remain connected. If you change the state of one particle, the other particle instantly changes its state as well. It's as if they communicate faster than the speed of light, defying the laws of classical physics. Could this instantaneous connection hold the key to teleportation? Some scientists believe so. If we can entangle particles over long distances and manipulate their properties, could we use this connection to transmit information or even matter instantaneously? While still theoretical, quantum entanglement offers a tantalizing glimpse into the possibilities of teleportation. It suggests that the universe may be far more interconnected than we ever imagined. Another potential avenue for teleportation lies in the realm of general relativity wormholes. Imagine space-time as a fabric. A wormhole is a theoretical shortcut through this fabric, connecting two distant points in space-time. Think of it like folding a piece of paper in half. Now imagine a worm burrowing through the paper, creating a shortcut between the two sides. That's a wormhole. By traversing a wormhole, a traveler could theoretically bypass the vast distances of space and arrive at their destination almost instantly. It would be like stepping through a doorway into another part of the universe. However, wormholes remain theoretical constructs. Creating and stabilizing them would require enormous amounts of energy and manipulation of gravity itself. The challenges are immense, but the potential rewards are equally extraordinary.
While the prospect of teleportation is exciting, we must also consider the potential dangers. What happens when matter is deconstructed and reconstructed at the destination? What are the risks of spatial displacement and environmental disruption? Imagine a teleportation process that isn't perfectly calibrated. What if the arrival point is slightly off? A person could materialize inside a wall or worse. Even a minuscule miscalculation could have catastrophic consequences. Then there's the issue of energy release. The sudden dematerialization and rematerialization of matter could create a massive energy surge, potentially resulting in a powerful explosion. Imagine a sonic boom amplified to a terrifying scale. These are just some of the challenges and risks we must address before teleportation can become a safe and reliable technology. Section 5. When gravity fights back the physics of instantaneous travel, teleportation also raises fascinating questions about the fundamental laws of physics. For example, how would gravity affect an object during teleportation? Would it experience a sudden shift in gravitational forces, potentially causing damage or instability? Then there's momentum. An object in motion has momentum. If we teleport that object, does it retain its momentum at the destination? If so, what happens when it arrives? Imagine a car teleporting from a highway onto a city street, its momentum unchanged. Disaster would be inevitable. These questions highlight the complex interplay between teleportation and fundamental physics. We need to understand these interactions fully before we can even contemplate teleporting large objects, let alone humans.
Section 6. Time Traveler's Paradox. Unraveling the threads of causality. Teleportation also raises mind-bending questions about time travel and the nature of causality. If we can move through space instantaneously, could we also manipulate time itself? Imagine teleporting to the past. What would happen if you interacted with your past self? Would it create a paradox, ripping apart the fabric of time itself? These are questions that have puzzled physicists and philosophers for centuries. While time travel through teleportation remains purely theoretical, it highlights the profound implications of manipulating space and time. The potential consequences, both intended and unintended, are profound and potentially catastrophic.
Section 7. The Philadelphia Experiment Revisited. A teleportation simulation. To illustrate the potential consequences of teleportation gone awry, let's delve into a fictional scenario inspired by the legendary tale of the Philadelphia Experiment. This experiment, rumored to have been conducted by the US Navy in 1943, aimed to render a ship invisible to radar. Imagine a modern-day version of this experiment, where scientists attempt to teleport a naval destroyer from one harbor to another. The experiment begins successfully. The ship vanishes from its original location. However, instead of reappearing at the intended destination, something goes wrong. The ship rematerializes partially embedded in a nearby island, its hull fused with rock and metal. Crew members are scattered across the deck, some fused with the ship itself, others grotesquely contorted, victims of spatial distortion. The surrounding environment is in chaos, trees uprooted, buildings reduced to rubble. This chilling scenario, while fictional, serves as a stark reminder of the potential dangers of teleportation. It underscores the need for meticulous research, rigorous safety protocols, and a deep understanding of the fundamental laws governing space, time, and matter.
Section 8. The limits of teleportation. Constraints and challenges. Despite its allure, teleportation faces significant limitations and challenges. One major obstacle is the sheer amount of information required to describe a complex object like a human being at the atomic level. Imagine trying to transmit the blueprint of every atom in your body. The amount of data would be astronomical. Even with the most advanced computers, processing and transmitting this information instantaneously seems impossible. Then there's the issue of energy consumption. The energy required to dematerialize, transmit, and rematerialize a human being would be enormous, likely exceeding the output of even our most powerful power plants. These are just a few of the hurdles we must overcome before teleportation becomes a reality. While the challenges are daunting, the human spirit of innovation and exploration is relentless.
Section 9. The power and the peril. Wielding the ultimate force. The potential applications of teleportation are as vast as the universe itself. Imagine a world without cars, trains, or airplanes. Transportation would become instantaneous, transforming our cities and our lives. Global communication would be revolutionized. Imagine video conferences where participants are virtually teleported to a shared space, enabling true face-to-face interaction regardless of location. Teleportation could even pave the way for interstellar travel. Imagine bypassing the limitations of traditional spacecraft and beaming humans to distant planets, opening up a new era of space exploration and colonization. However, with such power comes tremendous responsibility. The potential for misuse is significant. Imagine terrorists using teleportation to carry out attacks or governments deploying it as a weapon. The ethical implications are equally profound. How would teleportation impact social structures, economies, and individual freedoms? These are questions we must carefully consider before unleashing such a transformative technology upon the world.
Section 10. Teleportation, a future of possibilities and responsibilities. Teleportation, once confined to the realm of science fiction, is now a tantalizing possibility within the grasp of scientific inquiry. While significant challenges remain, the potential benefits are too great to ignore. As we venture further into the 21st century, we stand on the cusp of a new era of scientific discovery and technological innovation. Teleportation, with its promise of instantaneous travel and communication, could reshape our world in ways we can only begin to imagine. However, we must proceed with caution and responsibility. The power to teleport is the power to reshape our world, for better or for worse. It is a power that demands our utmost wisdom, foresight, and ethical consideration. The future of teleportation, and indeed our own, depends on it.